How's it going, everybody? Andrew Robinson here, back at it with another Max MSP tutorial video. In this video, we are talking about the Itable object. The Itable object is one of my favorite objects because the Itable object is a graphical user interface object that has a lot of really cool built-in features, and most people don't seem to actually know about this, so I'm very excited to talk about those built-in features today. The main one being weighted probability, which is a really cool type of randomness that we can use to make a lot of really cool things. So let's just first jump into the parameters of the Itable object. When you create the Itable object, you give it the name Itable. It's going to turn into this. And this is what I mean when I say a graphical user interface object. There are a lot of objects in Max MSP, but not all of them are graphical user interface objects. If it is a graphical user interface object, that means we can click on it and drag things around here, like I'm dragging all these little pixel dots around. And there are a lot of objects that are very similar to this in that we can click and interact with them. And they've got graphical displays instead of just the regular object types. The swatch, which we talked about in the last tutorial, is another example of a graphical user interface object. So with the Itable, we can click on it and we can open up the inspector and we can look at some of the parameters here. Now, the main two parameters we're going to look at are the table range and the table size. And this is what is actually our X and Y size for our Itable. So if we change the table size, we're going to change the amount on the X dimension, which is how many squares we have. By default, it's 128. I just changed it to 10, and now you see we have 10 little sliders. And same thing, if we change the table range, that's our Y value. So if I change that to 10, we're now going to have 10 squares that can go up to essentially the 10th pixel of the Itable, starting from 0, 9 being the max, so that gives us 10 values. That's essentially how it works. And that's pretty cool. Now, the way this works is basically you would click on it and you would set these squares to some value, and then we're going to get a return of the value out of this outlet when we send it a bank. So if I create an integer box and I attach that outlet into that integer box, and then I create a button and I attach that into this inlet here, and then we click on it, we're going to get a number, so 7, which means it just returned this value right here, I think, because it is returning the X value. And if I click on it a lot, you'll see we are getting all of these random values, and that's what it does. Every time it gets that bang, it's going to output a random value. Now, what's really cool about the way this does that compared to just your basic random object is because it uses that weighted probability built-in feature that I was talking about. Now, what is weighted probability? So weighted probability is essentially random, but there's a possibility that you will get more of a certain random value than others. So say you're picking a random value between 1 and 10, and the 7 has a really high weighted probability. It's going to randomly pick a number, between 1 and 10, but it's going to pick that 7 a lot more than the other numbers. And you can actually set that up on using this Itable. So if we set them all to 0 and we click this button, of course we're going to get a 0. Now if we set this middle one here, which is 5, all the way to the max, and we click this button, we are only going to get that 5 as a return because it's the only one that has any kind of value set to it. Now if we take this 6 and let's do the halfway spot, so it's at Y5 now, whereas 5 is at Y9, and we click this button, you'll see we are getting 5s and 6s. Now, we should be getting, and you can see it is actually working, because every time I click this button, we should be getting more 5s than 6s. And you can see there are, in fact, more 5s than 6s. So let's throw this 9 in here, and we'll have this not all the way down, but just on the second level, the Y1. So now we'll get a lot of 5s, a lot of 6s too, but not as many, and we'll get 9s every once in a while, which it seems to be working out that way. We're getting a lot of 5s and 6s, but every once in a while, that 9 does pop in there. So that is the weighted probability feature. You are getting a random return of the X value, whatever you have your X set to. So X x5, x6, x9. You can see them in this little key grid corner legend thing. We are getting a returns of the x value. The higher it is on the y value, the greater its probability that it will be the return value. So when you have it all the way up here at the highest y level possible, that is the highest amount of possible return value that you could get for that random value. This would be like 50%, this would be like 10%. That's essentially the idea. And there's a lot of other ways you can, get random returns from this. You could do it sequentially using some messages, but if you just send a bang to the Itable, that is how it works. And so we can use this pretty intentionally to do some pretty cool sequencer patterns where, you are influencing, it is random, but you're influencing the probability of those random. So let's just hear what something like that could sound like. And to do that, we're going to whip out our old friend, the K slider, which creates this cool piano. This is also a graphical user interface object because it's a keyboard and we can click on it and get a return, so it's interactive. That's the graphical user interface part. And all we're going to do is we're going to take this value, we're going to add something pretty crazy to it, like, I don't know, 69 sounds nice. And then we're going to patch that into the K slider, and then we're going to create a make note combo and a note out combo. This is going to format whatever pitch is played with the correct velocity and duration, which I'm setting to 120 and 500, and then we're just going to patch those out into the note out. And now when we click it, we should hear a note, and every time we send this a bang, we should hear a note as well. And you can see it's going to be one of these three notes. All of these are set to 0, so it's not returning those ones, but we could bring those in if we wanted to. So that's how we can start to kind of create, a random sequencer. It's random playback, but it's got, probability in it. I'm going to say that a lot. Certain values are more likely to appear than others, so you can get a little intentional with it. You could have like if you knew music theory, you can have your tonics, your fourths, your fifths, like set to pretty high values because those are like standard consonant type sounds. And then you could have your minor seconds and major seconds and things also in there, but at a slightly lower probability. So they're happening, it's possible, it's just it doesn't happen all the time. So you get a little flavor of tension in there rather than like just constant like dissonance. And that's pretty cool. And it's not just music that we have to map this into. We can map this into anything. We talked about the jit.lcd in an old video, so let's pull that up. We're going to use jit.p window here, so we have an in-patch patcher window. And then we're going to create that jit.lcd object. We're going to give it 4 char, 64480. There's some basic setup stuff. As we talked about in the LCD tutorial video, we're going to do load mess brgb000. So the background is black. I think that's just going to look nicer. Then we're going to do a load mess, and we're going to say clear, which will initialize it on starting up the patch. And then I'm just going to lock it. Double click these real fast because that's going to send their message out through the patch cord. So this jit.lcd is ready to go. And then let's also send in the load message pen size, and we're going to say 5.5, so we have a nice thick stroke. And then we're going to do something. We're going to set up the painting messages, and there's a lot of ways we could do this. We're going to start first with our list of our 4 variables, which is our top left corner and our bottom right corner. And then we're going to do 3 more for our RGB color, and then a 8th value, which will be our alpha. And we're going to then use the prepend message because we have to send this list to a message like paint rect to paint the rectangle. Watch my jit.lcd tutorial video for more details on it. If you're wondering about that, we're going to patch this into the prepend message, and then we're going to actually change the message that is set in prepend by using another message, that message being set. So if we say set, it's kind of going off to the side of my window. Let me move this over real fast. You see it says set prepend method, replace the stored message. So we can replace the stored message of prepend using the set message. So we're going to say set paint oval if I can spell it correctly. Then we're going to say set frame oval, and we're going to copy those. We're going to say set paint rect and set frame rect. And there are more shapes we could throw in here if we wanted to. I'm just going to use these four just for now. We're going to patch all of these into that pre-penned message. Now the next step is we need to draw the coordinates. We need to pick a color, and then we need to pick one of these messages that it's going to be. So we have to do things in a very specific order for that to work. So we have our random value here, right? This is our random probability. We're going to use a send object, which we can just use the message S for. We're going to give it a name like prob, so we know what it is. And that is going to link up to a receive object, which is just the letter R. And as long as they have the same name, which they do here, they're both called prob, whatever is coming into this inlet is going to come out of this outlet, which is super cool. And then we could just take that number and we can use that as our initializer to make sure everything happens the way we want. We just need to also include a trigger object. So first, this is going to spit out a random value. Then that number is going to go into a bang object. We're going to just start with 1B. So trigger bang. And this is going to go into its own random object, which we're going to set to 4 because we have 4 messages. So we'll get a random value between 0 and 3 because it's 1 less than what you define random as. So that bang, going in the random, going in the cell, whatever number it hits, it's going to send out one of these messages. Which is pretty cool. And actually, rather than, you know what, I've decided rather than doing it like this, I'm sorry, we're not going to use this random object. Instead, I'm going to use a modulo object, which is going to wrap whatever number that comes out of here around to be between 0 and 3, like we were doing with the random, except now rather than it being random, it's going to be pretty specific because this is a math operator. So if this is like 8 that comes through here, let's just actually attach a message box so we can see directly. We sent an 8, so 8 came out through this patch cord. We modulo divided it by 4, which means we just get the remainder value, which 8 divided by 4 is 2, so there is no remainder. Therefore, it's 0, which means that 0 came out through this and turned into a bang through this patch cord, which hit this set message, which then set this prepend object to be paint oval. So this would now say prepend paint oval, and then whatever list we sent to it would paint an oval at those coordinate points with that color. So that's the next step. And if we have our value coming through, so for the actual location it's going to draw at, we will do something. We will make that random, and we're just going to say random 600 because what I'm thinking is we have our X and our Y. It's 640 by 480. The largest size circle I'm going to want is like a diameter of 40 pixels. So I am subtracting 40 from this edge. Therefore, we don't draw anything off the side of the window. That is the thought. And then same thing, we're going to copy this and we're going to do 40 less than our Y. So 440 for this random. And then this is going to go into a trigger object like we were talking about originally. We're going to say I now. This patch cord's going in here. This one's coming out of this outlet because this has to happen first. We have to first set the message, our drawing command message. That is very important that happens first. And then after that message is set, it's all ready to receive the list, whatever the list is going to be. So that integer is then going to come out here. And that is going to actually not be an integer. We're going to actually have this be 2 bang. So our integer, we only want to pass the integer value to the modulo. Then we're taking a bang and we're going to say bang here on this random, bang here on this random. And then we also have to then create the coordinate points, which we can do by subtracting a certain value. We'll just set 10 in there by default. So now our top left corner will be 10 pixels back from whatever XY position we determine, and vice versa. We're going to then add the same value to the same random number, so we're moving 10 in the other direction. And that will center our coordinate points to be in the center of whatever shape we draw. And then if we want to change the size of the shape, we just have to change this value instead. So we are going to actually then turn this into a bang and add another eye here. Make sure this is coming out of the right patch cord. So integer first, then we're going to have a bang, which is going to pick, actually, hold on. I am thinking as I'm doing this, we're going to turn this bang into an eye. So integer comes out here, modulo divides, does that whole thing. Then the integer value, which we now our highest x value is right now 9. I'm going to actually just real quick, I'm going to change this table to 12. So we have like a full note octave range. That's going to be the idea. So now the highest value that can come out of our I table is, oh, it's actually 11 because of course it's one less. So we're going to set it 13. Now we get one less so that we get our full 0 through 12, which would be our tonic and the octave and everything in between, hopefully. So that's set up and ready to go. So we're going to get that out. The highest value it can be is 12. So knowing that, we're going to use a scale from 0 to 12, and we're going to scale it from, I said the largest is, let's do 40. 40 to like 5. I don't know. This is kind of arbitrary. The 0 through 12 is obviously based on the size of the table, but this is just the size of our shape. That could be anything you want, and you know, whatever looks good to you. But after you create that, you're going to patch that into all of these right inlets so it changes the operator number. And now once again, we're setting the message for the prepend. Then we're creating out of this, we're changing the radius or diameter size of our shape, and then we're picking coordinate points for that to go wherever it wants to go. Let's see, the very last thing that needs to be done is we need to also then pick a color, which I think would be cool if we just took the same scale here. And we're just, rather than scaling our notes to be our radius size, we're going to normalize it by scaling it between 0 and 1. We're just going to pull from this same outlet. Should be okay. And then we're going to create a swatch object, and we're going to send it the HSL message, $1, full saturation, half luminance. So whatever value it is going to go right across the middle of our swatch. It only needs one variable to do that. Then we're going to unpack whatever it is. We're going to need to slide a scale in here because it's going to be normalized between 0 and 1, but we need a color value between 0 and 255. So we're going to do that, patch that into the unpack, and then this is going to go right into these inlets. Not the last one, this is our transparency value. So that's going to be its own determination right now. Which, you know, there are a few ways we could do that. Instead, we're going to turn this last I just real fast into a hard-coded value. And we're just going to click to see if this works. And actually, it should be working. The issue is the jit.lcd also needs a bang. So again, we're going to use the trigger object. We're going to make sure that it bangs all this stuff first to make sure our operation happens in the correct order. And then we're going to send a bang out to the jit.lcd to then output the frame of it doing all this calculation stuff. So click everything again, just make sure it's all reset, ready to go, bang. And that's pretty cool. And you can see that we are sort of actually getting a sort of set emerging pattern. A specific note is related to a specific shape and color and size. That note, that red circle is always the same note. So that's pretty cool. And then, you know, whatever you do here in this I table, it's going to change the formula for this. So we'll reset everything by double clicking that stuff again. And it's really cool. You really could get pretty carried away with this and crazy. Let's add a metro in here so I don't have to keep manually clicking everything. We're going to say metro 500, and we're going to say at active 1, so it's just on and ready to go. And look at that draw. So that's pretty beautiful. We're gonna actually patch a toggle on here so I can turn it off. And with that, let's, I don't know. That's the idea. We are using weighted probability. We can influence things to happen more frequently than others, which gives us, maybe specific notes in a note sequencer, or specific shapes and colors in this kind of visual sequencer. And you could really, change how this works if you wanted to, all just by changing the Itable and throwing in there whatever you think is interesting. So that's really, really cool. And there's no limit to what we could do with this. We could copy this Itable here, and then, make it smaller. And then rather than having this one be like our notes or our shapes, we could scale that 0 to 12 value to be something like, let's say 60 to 120, and set that to be our velocity. So if that goes in there, that goes in there, we're going to get, changing velocity of notes based on weighted probability now too. And it's its own table, which means it's independent from this, which is cool. You can influence those independently. This could, then scale to something else. We could have this be our transparency opacity value. So if it's a really soft note, we could say it's really transparent, and if it's a really loud note, we'll say it's not very transparent. That'll come right out of here, and then right in there. And now our velocity and the opacity of the shape are the same, which is pretty cool. And again, there's no stop to this. You can use this to create whatever kind of random probability sequence you want. So hopefully you find that helpful. Hopefully you find it interesting. Hopefully there's something in this video that you didn't know before. If that is the case, please remember to like and subscribe, because that's how I know that you found this video helpful, and I always really appreciate it. We have come a long way since we started, and it's cool to see that going still. I really am thankful for everybody's support. I would not be where I am without you guys, so seriously, thank you so much. If anybody has any lingering questions about anything that I said, please leave those in the comments down below. I will answer them if and when I can. And on that, I look forward to seeing you guys in the next video.